Question number 1. How does a loudspeaker interact with a room? Let us consider a room with a given volume V and reverberation time T. There's a loudspeaker somewhere and a listener somewhere. And we're going to look at the echogram, the sequence of echoes that reaches the listener coming from the loudspeaker. At some given time, the loudspeaker plays an impulse, and after a time, depending on the distance, the direct sound reaches the listener. Direct sound which does not depend on the room. It has a given energy, E dear, and then after the direct sound, a sequence of echoes arrives at the listener, first order, second order, third order reflection, and it is usual to consider the energy of these echoes reaching the listener within 50 milliseconds after the direct sound. That's the sum of this energy with the direct sound energy is called the early energy. It contributes positively to the speech intelligibility. After that, the density of echo increases with time, and there are so many echoes that we look at these echoes in a statistical sense, and we characterize these echoes by the total energy, the E late energy, and also by the reverberation time, which is the time it takes for the sound to decay by 60 decibel. We're going to listen to an example with a 4-second reverberation time, which corresponds to a highly reverberant space like a church. Right. The early energy depends on the source to receiver distance, of course. If the distance is short, then the direct sound is high. If it is long, it is weaker. But it also depends on the source directivity. If the source is non-directional, then the direct sound is rather weak. If it is highly directional, then of course it is stronger. The direct sound is more energy. The late energy it varies proportional to the reverberation time and inversely to the room volume. And the important thing is that it is constant throughout the room, as opposed to the direct sound, which of course depends on the receiver location. Late energy is not dependent on the receiver point. And it has a negative impact on the intelligibility. Let's listen to an example with a 4-second reverberation time again, which corresponds to a rather low intelligibility. Okay. Now let us compare to the case where the RT over V ratio is low, and then lower late energy and therefore better intelligibility.
This is a test for speech intelligibility assessment.